Good afternoon. Welcome to the second presentation from GB Labs for Broadcast Asia. Today I would like to go through some of our technology and make some comparisons with other technology available, and also detail a very interesting installation for a very forward-thinking broadcaster. So let's begin. Modern workflows are very challenging these days. Obviously 4K has been around for quite a while now. 8K is becoming more commonplace, and further resolutions, future resolutions and demands will obviously keep pushing storage. So performance and capacity have had to grow. And in the case of certain customers, especially with deadlines, etc., high availability is also a major concern in the equation. So I am personally a big believer in NAS, no surprise. Obviously, I work for GB Labs and we do network attached storage and archiving devices. Some of the main reasons that NAS is a far more logical and appealing platform than any other storage, or certainly any other high-speed storage solution, I've listed here. So no client licenses, no client software, standard, industry standard connectivity, totally cross-platform, and appliance level simplicity. Or certainly this is what we would expect from a NAS, a modern day NAS. The obvious comparison will be to SAN, and SAN has been around for a long time. Certainly I came from a SAN background, and there are many things about SAN that were necessary back in the day. They are not necessarily necessary at this point in time, because we've proved for a long time now that NAS, if it's done properly, can deliver very good performance to users on the network. SAN is effectively crippled by having a metadata controller, so that all requests will come through the single metadata controller. Even if you do have multiple metadata controllers, they will generally be set up in failover, so they don't have the opportunity to load balance high activity or lots of connections. So generally, accessing a single storage pool over 40 users with a SAN is problematic, and certainly if those are high bandwidth users, the problem is amplified. NAS works in a slightly different way, because it's not managing block level storage, or certainly it's managing it within itself. It's offering out storage to the network using standard sharing protocols and also industry standard connectivity. It's very easy to run high bandwidth, high intensity IOPS operations, and we avoid the contention of metadata, or rather having to control users accessing the block level storage. We have the access to the storage, and then obviously we're presenting it to the network. High availability is something that a lot of people talk about. They talk about no single point of failure, and it's quite interesting once you start looking at the available options out there, certainly the ones that would cater for high performance usage. Predominantly clustered file systems are the way that most people would put forward to do this, and they do offer, a reasonable amount of protection. It is, however, usually not mentioned that if a node within a cluster fails, you're generally looking at a minimum of 10-second interruption, followed by a reallocating of data within the clustered file system. So even disk loss, or even a large deletion from the file system will require re-optimization. So you're looking at a situation where not only have you lost a node, yes, you're still carrying on, but you are crippled in terms of performance. Our CloakDR system approaches disaster recovery in a very different way, and we absolutely advocate that you have two systems talking to each other, and presenting themselves as a single IP address. This means that routes from servers, clients, etc. on the network don't change if you have complete hardware failure. Now, a cluster is, as we said, very well protected, but if you go back to any of those cluster manufacturers and you start discussing true disaster recovery, they'll tell you to go and buy another cluster, which as a solution then becomes extremely expensive, and you have difficulty with managing the switchover between the two. And typically, if this ends up being a manual process, this can be incredibly time consuming, rerouting all your clients and servers to a different destination, only to fix the problem subsequently and have to redirect everything back again. Our Cloak DR maintains the same IP address, and simply within 2 seconds, the other server takes over. So you as a user probably wouldn't even notice that I'd gone along and removed an entire server. And certainly we advocate putting these servers in completely different locations. And with the beauty of IP or Ethernet connections being long range, we can really separate our assets properly, whether that's a different server room in the building or whether it's a completely different building. It's completely possible to put your assets in 2 different places and create a true DR strategy. I'd like to discuss this afternoon one of our clients who is extremely forward-thinking broadcaster in the Philippines, GMA Networks. They last year, or just the year before, set out a specification for true 4K production and the ability to have over 65 workstations editing from a central location. They obviously wanted to cover all sorts of things from color, CGI, everything to do with the 4K production. GMA are quite unique in terms of they produce their own content and wherever possible will do the work within. So the facilities at GMA are quite extensive, and their requirements were specified for a system that could deliver over 10 gigabytes per second. So that's 10,000 megabytes per second. The discussions progressed, and this figure grew to 15 gigabytes per second, which is no mean feat. And it meant that at the point that they put out their specification for other companies to tender for, it narrowed the field very quickly. There are literally very few people that can deliver this kind of performance. Of course, they were then looking for resilience combined with that, which narrowed the field even further. So each manufacturer was given the opportunity to prove their technology within real-world POC testing. It's quite rare these days. You know, we have lots of discussions about theories, what things will do, what they should do, what they shouldn't do, but to actually sit and test and to put real-world load on a system and then start failing things on purpose is very much the thorough testing that we were subjected to alongside every other manufacturer in this equation, which, you know, I openly welcome because it really does sift, you know, the bad offerings or the good offerings from the bad offerings out there. So the field was narrowed down eventually to 2 manufacturers who, including ourselves, obviously, who could meet the specifications for the tender, or at least we all applied to do that. It turned out in the final POC sessions, actually the other competitor, whilst their peak figure or their cached peak figure was very impressive and on paper kind of looked like it was a tick, once it was actually subjected to testing, it wasn't able to deliver quite what the manufacturer was promising. To exacerbate this further, the cluster, when it did suffer failure, or node failure in this case, the effects were actually quite dramatic and unexpected, or certainly not marketed in terms of what the systems will do. So it was quickly proven that our system could not only take hardware failure, it could also maintain very good performance throughout. In fact, the system that we provided is slightly faster than 15. It actually produces 18 gigabytes per second, which is a very high output. So this is a picture of the initial servers. They're all based around our Space SSD platform. These are then expanded out, and then you have two sets there. So in a 2U form factor, it's actually a very compact, high capacity, high performance system. The performance characteristics, being pure flash, are incredible. So the IOPS of the system, its capability to deal with lots and lots of small requests, small files at the same time, it is also fantastic. And in this particular case, we were asked to obviously prove this performance throughout removal of disk, power supply, and entire server failure. It was also then asked to recover from that failure, and with the automatic synchronization that happens with our servers when you bring them back up again, and pretty much the one button press to switch priorities on those servers, it couldn't be simpler to lose a piece of hardware, deal with the problem and put it back. Similarly, if you need to remove a server for maintenance purposes, for firmware or anything that would require the server to shut down temporarily, it's ideal because you can remove a server, deal with it and put it back into the cloak, and do the same with the other server, and you can do that in a very safe way. Obviously, the massive benefit there is that you're maintaining a connection to the central storage throughout. The Space SSD platform is very interesting in that one box will deliver 6,000 megabytes per second. With two chassis, we can reach 12,000 megabytes per second, so 12 gigabytes per second. And finally, as they had, an 18 gigabyte per second system. This was then paired to another identical system and then delivered out across switches to give a no single point of failure system. In fact, I'll detail the network slightly more in a future slide. But needless to say, we have two completely separate servers that are communicating with each other. There's a heartbeat running between them. They are acutely aware of the presence of the other unit, and they are also acutely aware of where the data is in synchronization. The technology is very interesting. Data will always be written to both. It's not a case of writing to one and migrating, copying, or anything else between the other server. It's literally data is written to both, which means at any given point in time, the data on both servers is identical. The reading will come from one server. And in fact, there are other modes within the Cloak software to include the other server to give some small benefit in performance, but primarily the secondary system is sat there listening and waiting to take over should it need to. The process is really as simple as if I go to shut down my primary, my secondary will take over. When I bring my primary back, they talk with each other, synchronize data, and report back that they're happy and they're in the protected mode of seeing each other within this Cloak DR technology. The Cloak itself is a unique technology to GB Labs, and it does ensure that business continuity is within that 2 seconds I mentioned, which 2 seconds is within what most playout or ingest servers will deal with. It's something that if your non-linear edit suites were working from a central storage, you would probably just notice the playhead stop. At the point that you then hit the spacebar again, you're actually working from an entirely different server. But for you as the user, it doesn't seem anything has changed. And it could be, as I said, that an entire server rack or room had burnt down and you were working from another server room. It really is that simple and that well protected from a DR point of view. The system, as it stood is a very well protected system and what I would call no single point of failure by design. So alongside our servers being resilient, the switching needs to be resilient as well. So GB Labs will produce a complete system for you, including the switches with everything configured, and this can be provided as a solution, but it will also bolt into other people's switch architecture. I'm often asked, with this level of protection, do we also need to have this level of protection in the switches? And the answer is, well, actually you don't. There is a massive benefit in terms of it's a hands-off experience. If one switch was completely die, packets would be rerouted, access to the storage would be there. But if you weren't in the position of multiple switches configured in this way, then actually, if there was a switch failure, it could be as easy as going in and switching that over. So for the more simple deployments or where it's interfacing with your existing hardware, it's not a problem. But by design, we obviously like to incorporate the switches as well, and that's something that we will provide as an entire delivered solution. The interesting thing here is that at 20,000 megabytes per second, I kind of figured that the customer would have been satisfied for a while, but discussions have already been in place for going a lot faster and also for adding more storage. And we are already discussing performance at over 30 gigabytes per second, and I found a way that we can push beyond that as well if required. It's very interesting to work with a client that has such big expectations from their storage, but at the same time, realistically, we can deliver them. There isn't obviously a whole load of customers out there with exactly the same requirement, but this is a very good example of a lot of creative workstations working with 10 gig Ethernet, being switched in a resilient way and interfacing with extremely high performance pools of storage. That storage is obviously resilient as well, and as a system, uptime, performance and expansion in the future in terms of performance and capacity are obviously hugely important parts of this. I very much look forward, and I've kept on my radar to look for other storage systems that can approach this realistic sustained level of performance, and I've yet to see anything that would take this on in a performance battle as such. It's very easy to look at peak performance figures, it's very easy to look at cache figures and to think that a system will do that day in, day out. It's actually a completely separate and very much important thing to consider here, that actually if your systems are busy most of the time, as you would find in a broadcaster, even through the night or over weekends, this system has to be able to deliver massive performance, and it has to do that sustained every day. We've talked about protecting against the interruptions, but the reality is the pure flash technology that GB Labs has been pushing for a long, long time now is really one of the only sustained central storages that you can work from in such an aggressive way with such large work groups. And we mentioned at the beginning of this presentation that the restrictions are there for SANs in terms of you can only have about 40 users looking at a single workspace. Well, here we could potentially have hundreds of users looking at a single workspace. And that's the beauty of NAS. It allows us to do these things, but obviously by incorporating best of breed hardware and our unique operating system, we have been able to push the limits, or to really sort of set records here. I very much look forward to going beyond this and the demands of future workflows, but this is something that is in place, has been for quite a while now, and has diligently done its job and is really waiting for future expansion to happen to allow more creative users to all work together within this ecosystem. So thank you very much for your time in watching this presentation this afternoon, and any further questions or any details you'd like to pick up, we are here, we have a booth, and I very much look forward to your questions, and we'll get back to you as quickly as I can. Thanks very much. Bye-bye.